All right, so this is the point at which we left off. This is the point at which we left off at the end of the last video, and we saw that we were able to convert this back to a system of equations and solve it, which was ultimately that was our goal. So great, but we need to go further than this. In order to answer deeper and larger questions, we don't just stop here after we get this triangle of zeros. Yes, that is sufficient usually to solve the system if it's a consistent dependent system. But for other systems and for other questions we want to answer, not only do we need a row of zeros here, we also need a row of zeros here. So what we're about to do may seem like overkill, but you got to remember we're doing this because we want to answer other questions, and specifically, we're 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 more interested in those systems that have zero or an infinite number of solutions and what information we can gain from them. Because if it's just got one solution, then it's pretty cut and dried. So we want to create that upper triangle of zeros and get and see what we end up with there. The other thing to think about here is if you go back and look at those green matrices that we created in our previous video and follow the progress of them, they got simpler and simpler. So therefore the systems that were associated with each of those matrices were simpler and simpler to the point where they got so simple that we could solve them. In fact, this bottom equation was simply x sub 3 equals 3, and then we start back substitution. So this elimination process is producing simpler and simpler matrices. So the question we have, and we're going to attempt to answer, is can we just keep simplifying? Because although we were able to solve this system in this form right here, we still had to do some work when we had to do some back substitution and substituting into the above equation and solving for the unknown variable. Can we simplify the matrices using elementary row operations to the point where the system is trivial? And we can, and that's what we're going to do. So we got zeros down here in this order, in this counterclockwise order. We're now going to get zeros here, here, and here in that order. So we're going counterclockwise around the matrix, creating these zeros. We're going to use the same elementary row operations to do this. So looks like to get our first target 0 right there, we need to multiply, or we're going to need to use row 2 and row 3. So we'll just simply, I think, go row 2 plus row 3, and that will replace row 2. Row 3 is where we want it, but we need a new row 2. So row 2 is this, and row 3 is this, and so when we combine them, we get the 0 that we want. Now at the same time, let's do our little trick of everything's divisible by -3, so we're going to multiply everything by -1/3, and that will again be our new row 2. So the matrix we get looks like this. New row 2, and same old row 3. Next target, 0 right there. Again, you may be screaming, but I know what the solutions are. That's not the point of this continued elimination, always. So we need to continue so that we can master it. I need a 0 in that -2 spot. So we're going to go, we'll take row 1 as it is, but we'll add 2 times row 3 and replace row 1. So row 1, 2 times row 3 looks like this. And so when we combine them, we get the 0 where we want it. And no tricks there to give us a simpler row. So that's our new row 2. Row 3 again unchanged. Row 2 unchanged. Oops, you know what? This is what I get when I'm thinking several steps ahead. That's our new row 1, isn't it? We were working on row 1, so let's make sure we get that correct. I apologize for that. So this is our new row 1. So it's going to be 1, 2, 0, negative 9, and then we get our 0, 1, 0, negative 4. So, yes, I think that's correct. So now we've got our zeros where we want them. In those first two positions, we now need a 0 right there to finish things off. And so to get that one, we're going to take row 1, and we're going to add negative 2 times row 2 to it, and we'll replace row 1. So row 1, negative 2 times row 2, and there's our 0 that we want, and a negative 1. And so that's our new row 1. Row 2, and row 3. And so what we've ended up with is triangle of zeros below this, which we call the main diagonal, and triangle zeros above. And that main diagonal is especially nice thanks to our division, little division operations. It's all ones. But look at this. This is the interesting thing, and this is why we did these extra steps. Look at the system that this becomes. X sub 1. Let's do it this way. X sub 1 equals negative 1. X sub 2 equals negative 4. X sub 3 equals 3. We've simplified it to the point where we just can trivially read off the solutions. And so that's why we do those extra 3 eliminations. Yes, again, we're not just trying to get the solution. We're trying to understand how systems work and the power of these eliminations, these elementary row operations that we can perform.